or Ask the Expert series of from 3D culture, and we will have more and more such series. Before I proceed, here is a confirmation that I'm seeking from all of you, that we are going to record the session. In fact, we are just started recording, but if there is any objection, let us know. The purpose of this recording is just knowledge sharing. It There is no any commercial purpose. It's more about sharing with more and more people, so that other can also get benefited with knowledge of our experts and the questions that you guys are asking. So if no objection, just raise your thumbs up and give me signal. Superb, superb. Thank you. Thanks a lot. So I don't hear any objection. Thanks, Abhishek. So it's perfectly fine. We are recording it. First and foremost, I like to thanks a lot Aviral for being here and our expert of the day. So welcome, Aviral.
Thank you so much, Vivek. Really appreciate that. Expert is a word that is a little difficult to swallow, but I'll do what I can to help out with whatever experience I've gained. Thank you.
I always admire your humbleness, Aviral. So we have Aviral. Unfortunately, our second panelist, Ajay, could not join us today. He expressed his regret for that, and it was some personal emergency. So it's happened, it's life, and we always need to adapt with the realities of life. So great that we are anyways progressing, and we have a viral. So I'm very much very confident that we will have very meaningful and very interactive conversation here. So and guys, feel free to ask question any moment of time. You can raise your hand. To raise your hand, if you go to the, if in your ring central in bottom bar, there is a raise hand facility. I So if you click on that, as you can see that my hand has been raised, and you can lower your hand by clicking on it. So before asking you any question, raise your hand, and I will definitely invite you to raise your hand, to ask to raise your question. Okay, and this is how we will be continue our discussion. So there is lots of advantage of being moderator. I can definitely start asking first questions, but I see Mudit, you raised your hand. Is it just
Ye-
a test trial, or you have any question or some remark?
I have a remark, not a question. So people who are logged in from a laptop, from Link Central website, from a web app or a app, it's on the bottom. But people who are joining from the phone on the app, it will be on the top, on the raising the hand button. Just an info.
Uh-huh. That's a very useful info, and you kind of make it public that I joined using browser. Thanks, Mudit. Thanks, Mudit. So there's, as I was saying, there's lots of advantage of being moderator. You always get opportunity to ask first question. So I will definitely going to leverage that position. And Aviral, tell me something about you, more from your more from 3D printing, or this additive manufacturing standpoint.
Ah, it's not a very long history, Vivek, right? I actually grew interested in 3D printing a while ago, but didn't do anything about it until the end of 2020. And that's when, in a conversation with somebody, I suddenly realized that I hadn't really done anything in this space, which I claimed was a piece of interest to me. So, what I've been doing since then is I've started reading a tremendous amount. I got my only printer at this point about a year ago, and I've been doing various things with it. I've used it, I've broken it, I've fixed it, I've used it again, and trying to do more and more different things, right? But uh, along the journey, I've picked up a
Mhm.
few things about FDM that I'm happy to share. Right, the only thing I'll say is that it's a very interesting hobby for me, and
Mhm.
something that just, once you look at something that you've created and you can hold it in your hand, um, that's difficult to compare that feeling to other things.
Yeah. It's like a mixed feeling of creator and artist and uh, user at the same time.
None of which I can claim by themselves. So I like that feeling.
That's nice. That's nice. And as we all know, probably this FDM is world most popular technique of 3D printing. Maybe because of economy of scale or any other reasons. And there are many techniques, but FDM definitely dominate it. And one of the reason, and with my limited knowledge, one of the reason that I believe is its economy. It's the usage, ease of use, or the availability of ecosystem. But the moment something become big because of economical aspect, there are always underlying challenges and issues comes with it. There is price for everything, and you have lots of experience in FDM. What kind of typical challenges or issues you personally experienced?
So FTM is a very interesting space, right? As you said, it's got a lower barrier to entry than the other kinds of 3D printing that we have. So the challenges in FTM space depend on a lot of different factors. So if you look at the FTM space today, right, you have a bunch of different kinds of equipment available that you can use, and what you want to do essentially dictates what you use, right? What equipment you use. So if you look at the various equipments, the first is if you talk about machines, right? There's two very different ends of the market with shades of gray in the middle. Is
Hmm.
one is a professional machine where
Hmm.
everything comes set up, right? And it's pretty much plug and play. You switch it on, you start working, and it works.
Hmm.
And the other end is the hobby machine, where you get something, you set it up, and whatever you want to do just doesn't seem to happen.
Hmm.
And that's when you start kind of learning, right? And putting things together. Um, and my experience, so I bought an Ender 3V2. The biggest advantage of the Ender machines is the community that they have.
Hmm.
And
Hmm.
whenever somebody has a question, I think the response seems like it comes before people finish typing their questions. I know that can't
Hmm.
happen, but it seems that way, right? So
Hmm.
it's very interesting from that perspective, and a lot of my knowledge has been gained by looking at the issues that other people have gone through. So what issues have I gone through? It's the gamut. So if I talk about my machine, um, I have a standard setup. I don't have a direct drive.
Hmm.
I have I have a glass plate, right, that I build on,
Hmm.
and most of what I've done till now is PLA, right. I've done decent amount of ABS too, but most of what I've done is PLA. So
Hmm.
given those ranges, I think every experience that you can take is something I've gone through. So what are the first set of experiences? Trying to level your bed.
Hmm.
My bed was impossible to level, right, until I got the yellow springs. Well, even now, it's not every 3 or 4 prints I need to level it again, right? But it's much better. Whether you talk about stringing, whether you talk about filament breaking, whether you talk about the surface not being smooth, I think there's so many things that you need to learn about your machine before you can tune it and get it right. And
Hmm.
having a hobby machine has allowed me to learn. Right, with one of the other machines at the other end of the spectrum, it would have worked,
Hmm.
but I would have never known why it's working. Now I know why. So a lot of challenges, but a lot of fun going through it. Latest thing that happened was that the heat sensor in my hot end gave up. So just
Hmm.
replacing the heat sensor and then going through everything that I needed to do to set it up again was a learning in itself, right? And that just
Hmm.
happened about a month ago. So it's been a lot of fun with all the issues.
Hmm. So this heat sensor thing is more because of the hobby printer, or it's more because of the nature, the way FDM works. Like it deposits this filament one by one. So uh, Is
Heat
it more of
sensor,
a FDM challenge or it's more of a hobby machine challenge?
no, it's a device challenge. A heat sensor on any machine can fail, right? There are actually um, um, not devices which are very strong. So if they're lasting, right? But at any point in time, they can fail. It's like a zero 0.1 mm bead, which actually does the sensing, right? And you have two wires attached to it, which are equally
Mm-hmm.
fragile. So
Mm-hmm.
both mechanically and property-wise, a heat sensor can fail. Not
Mm-hmm.
not very uncommon in any machine.
Mm-hmm. Yeah. Yeah. And you also mentioned about you also used ABS material.
Yes, yes.
So for you, you do some kind of workaround with this, gas thing and.
With the yes, I actually created an enclosure. I created
Mm-hmm.
a full filter, right? So
Mm-hmm.
I actually have a path. I wish maybe there's a photograph somewhere, right? But I actually have something which takes the air, passes it through a filter, and puts it back in to maintain the temperature of the enclosure,
Mm-hmm.
right? So
Mm-hmm.
I have that running from about 15 minutes before I start the print to about half an hour after I finish the print. So
Mm-hmm.
that's something I had to do for ABS.
Nice, nice. That's already a learning and kind of, a good experience, your personal experience that our listeners and can also use. Yeah. And at this moment of time, I will like to open. We got few pre-questions, but I don't wanted to read those pre-questions, but rather I like to open floor and see if from our audience if there are any questions. And I see Abhishek already raised his hand. Yes, Abhishek, over to you.
Yeah,
You are on mute.
yeah,
Yeah.
yeah. So I have a question. So basically, when I'm going to level up my bread plate, so I can see the distance between the nozzle and the plate from the center is something as compared to the edges.
So, Abhishek, that's a very common problem, right? Thank you for asking the question. Um, the problem we're talking about is essentially a warped bed because when you level a bed, you kind of do it in various points. So if you have a 5 point leveling, you have the four corners and the center that you're trying to level. And if your bed is either concave, right, or convex, then there's nothing that can really be done about it in terms of leveling because the actual points, if you keep it flat, the actual points are different, right? So there's a variety of things that can be thought about. So um, if you, for example, have a PEI sheet that you're using, right, and it's a concave bed, then something that you can do is put a couple of pieces of paper under the center. That will tend to kind of level it out a little bit, right, on the pressure. But if you have a convex bed, then that's not something you can do. I personally use a glass bed, and my glass bed is actually a convex. So the center is
Mm,
much meaning relatively higher than the edges. So that's something I have to work around. Now, the one way you can do that is to get an auto leveler. So you level the four corners, and if you get a BL touch or something and attach it to your machine, then it'll adjust for those contours on the bed. But remember, that's going to affect your prints. So the only real solution is to get a new bed. But the problem with that is you don't know if the new bed is going to be flat or not,
That's what.
right?
So which bread is
So I really
advisable?
wish. Sorry?
Which what kind of bread it is advisable? Because I'm having a Ender 3. So as you are saying,
Right.
you are having a glass bread. I'm not having a glass bread. I'm having a that fabric kind of bread.
Yeah, sheet.
So
Hmm.
which one is better to have it over there?
Look, I think that's something we'll need to research, right? Not using a PI sheet. I don't remember the brands per se, right? But there are ones you can get more expensive, but that doesn't mean that they're going to be um, um, flat as a given, right? The advantage you have with the PI sheet is that you can put a little bit of paper and adjust it to the point where it does an acceptable kind of job. But I think the only true fix to that is to get a BL Touch or one of those auto leveling tools.
Right. Okay. Thank you for the answer.
Anytime, mate.
Thanks, Abhishek, and thanks, Avril. Very crisp and why my voice is echoing. Yeah, it's better now. So thanks for answering. But it keep me thinking, and it's I may be going to ask a very simple stupid question. You mentioned about this challenges with concave or convex, or mainly with the bed. And since you also mentioned it's a very common problem, this nozzle things going in center and not on the corner, and it's very logical. If it is not flat, then this problem will simply amplify. So why we don't have more and more flat bed, and why this is the curve bed?
So that's a good question, Vivek, right? And I think if you that's actually a very common discussion. So question somebody had, right? So somebody broke their Ender 3v2 bed, right? The glass bed. And what they did was they used to work in a glass factory. So they just cut some glass and got it home. And that's when the discussion started. A normal pane glass, even the high quality ones that you get in the market, which you use on windows and other stuff, is very variable in its kind of height, right, depending on how you put it. Right? So the variation could be as much as half a millimeter. And for the FDM world, that's crazy. So what they do is the glass used for mirrors are much more accurate because otherwise they'll create distortion. But even those are accurate only to about 0.1 to 0.2 mm. So we need slightly better than that, right? So the best thing is get some mirror glass, right, and try to use it if you want that. But a little bit of variation will always be present. So, for example, I can see there's a variation in mine, but it's really not impacting my print quality as long as I make sure that I've leveled it in a way where all the 5 spots are have a decent gap, right, to my hot end. Right, if I level it only according to the corners or only according to the center, right, then my prints are not going to be very good. So I have to be a little bit more creative.
Yeah, super. And I see few more people joined little late. So just for kind of a rules of engagement of us here is, if you have a question, please raise your hand. If you joined using browser, in the bottom bar you find the raise hand. If you have joined with app or mobile, and I see Rajat already raised his hand, and then Rajesh. So first I will ask Rajat to ask question, and followed with Rajesh.
Hello, sir.
Rajat, over to you.
Hello, sir. Hello, sir. Sir, I have a question
Kind of.
on clogged nozzle. My printer is having nozzle clogging because I use multiple kind of material. Sometimes I use wood filament. Sometimes I use other filament. So, what is advisable? What would you say about which kind of techniques to use to have a good nozzle all the time? Or is it, should we not use particular kind of material in a nozzle? And it is about hobby
No, I
printers
think
as well.
sorry, I thought you were done. I missed the last part. Can you repeat the last sentence again, Roger?
Yeah, so last sentence, I was saying that should we do not use any particular kind of material in the hobby printer? That was the last question.
Oh, no. Let's not do that. So it's actually a very interesting question with a lot of points in it, right? So why does nozzle clogging happen in the first place? Nozzle clogging basically happens because there is material which stays in your nozzle and doesn't come out. It could happen because your nozzle is either too close to your build surface, right, or a variety of other reasons. Now, there's a few things we need to think about. Is you also get multiple types of nozzles, right? Recently somebody was talking about a ruby nozzle to print something. I don't think we want to spend that much if you're getting hobby printers, but they do exist, right? So if you talk about filaments like wood and marble and glow in the dark, those filaments are not easy for the machine to handle. And most of us are using brass nozzles, right? So for those nozzles, my recommendation is that look for a steel nozzle. You can actually find the recommendations for various kinds of filaments that you use. Um, the brass nozzles will get worn out quickly when you use these nozzles, and that will make the size of the hole different, which will affect your printing. But that is not a cause of the actual blocking of the nozzle, right? There's a few things that I can recommend from a nozzle blocking perspective. Is first thing, make sure that you check that your Bowden tube is flush against your nozzle. Because if that's not going to happen, what's going to happen is that there's going to be leakage of the melted filament above the nozzle, right around if the Bowden tube is not flush. And there's various techniques of making sure this happens. For example, there's a great couple of videos on cutting off that half inch and putting it in and pushing it in. I think that is a very, very good thing to do. I've made that modification to my printer. So make sure that it's flush. If it's not flush, the material will
Mhm.
actually flow into your hot end, which will be a problem. The second thing is when you change your material, right, that becomes a difficult thing to do because if you, for example, if you're going from ABS to PLA, ABS typically I printed about 235. Thankfully, my ABS prints at 235, and my PLA I print at 205. If I don't heat the nozzle to 235 before and allow and drain some of the PLA, which allows the ABS to also come out, then the ABS will remain solid there at 205, and that's going to be an issue, right? So make sure you heat it to the higher of the two. Let extrude some filament until you see only your target filament coming out, and that will be a better situation around doing that. The third thing is you can always kind of clean, right? There's a bunch of cleaning tools which are available, right? All of them. And cold pull, something I haven't done yet, but cold pull is the last option which will clean that nozzle completely. But cold pull is not for the weak-hearted, and I'm still a little weak-hearted, I think. Um, so those are the kind of answers. But I think the good news is that as long as your hot end doesn't get impacted, nozzles are cheap. If they're getting clogged, just start using another one, especially the point fours, right? They're widely available and quite cheap. So, but there's a few things that you can keep trying to unclog your nozzle or not get it clogged again. You can do
That's
one test,
real.
Rajat, right? Sorry, Vivek, just one comment.
No, no,
Rajat,
but
you
yeah.
can do one test, right? On when you've loaded up your new filament, and if you just tell your printer to extrude a few just make it a little higher, right? And you can see the filament come out of the nozzle. If your filament is clogged, you will typically see it come out of a corner and curl. If it's not clogged, typically it comes down straight. So you can do that experiment to check if it's clogged or not.
Mm.
So, back to you.
That's really interesting points, and I think you give lots of tips and suggestions, very useful for I think for all of us. But I'm just extending to the same tips and suggestions that you gave as your own practice, or maybe good practices for everyone. As like we know, for if I have car, every 6 months I go and I will do a servicing. I have a bike, I'll do like all these things, cleaning, nozzle checking, and every other suggestions that you give. Should like is it like every month, something like how frequent, how often? Is there kind of any standard servicing or thing?
I wish there was, Vivek. I'm sure with the more expensive machines, there will be a cycle and recommendations as to do these 25 things, right?
Hmm.
So if you look at a printer, right, there's two major kind of components to them: the mechanical and the electrical,
Hmm.
right? So on the electrical side of things, it's typically difficult to test until you are very familiar with electrical things, and you can dismantle and check all the voltages and check all the various components, right, to make sure they're working fine. But that typically you can handle if something breaks. On the mechanical side of things is something that I would really recommend is make sure that your structure is square. Make sure all your bolts are tight. In most cases, in some cases, like the eccentric nuts, you need to position them right. So make sure you go look at the mechanical side of things on a very, very regular basis. And the more you use your printer, right, the more you will need to do that, because um, that's what starts sagging, right? Your bolts become looser, your belts become looser, right? Your gantries start dipping a little bit. So regularly, I would say every 2 to 3 months, just make sure everything's still square. What's supposed to be tight is tight, right? Put whatever kind of I know there's a big debate, so I'm not going to recommend about what to put on your z-axis, whether nothing or some kind of oil or some kind of grease. There's a big debate on that, right? But whatever you do with your z-axis, make sure it keeps moving properly, right? So those are the kind of things that you do. But the one thing which is very important, make sure you take care of your build plate, right? Make sure you clean it, right? Make sure you do whatever is necessary. Otherwise, you're going to start having adhesion issues very, very quickly. It's been a year to date. I haven't had to use any adhesion techniques at all, right? All I do is clean it with warm water and soap, and I use isopropyl alcohol to wipe it between prints, right? So luckily for me, touch wood, adhesion has been great, but make sure you take care of your build plate.
Superb, superb. I think that's really very, very useful. And then I will request Rajesh to ask a question. Rajesh, you are on mute.
Hello. Yeah, hi
Hey,
everyone.
Rajesh.
Sorry, I joined late. I missed few points, very, very important points, I believe. Uh, yeah. So my point is, I'm a designer. I'm a creative person. I'm a painter and a sculptor and 3D designer as well. I have a question. Uh, yeah, I do 3D designs. Okay. So what will be the additional requirements for the 3D designing persons to to add into it for 3D printing or entering into 3D printing world? Yeah.
Thank you, Rajesh.
Please.
I'm getting goosebumps, right? First of all,
Yeah.
because I will say it right now, I am so jealous, right?
Oh.
I do designing for 3D printing because I have to, but I can't even draw a straight line. So I am so jealous of the skills you have. But you have a very, very good question, because 3D design skill as relates to 3D printing
Yeah.
actually requires a lot of care, right, that we need to take. So
Mhm.
let's talk about FDM a little bit, right? And Vivek, is it okay if I take about 3 minutes or so to answer this? Okay, good. Okay. So if you look at 3D printing, and you look at any of the stress tests that people do within 3D printing, right? There are three things that people look for in terms of how well a printer is printing, right? Um, Two of them are structural, and they are overhangs and bridges, right? So let me talk about
Okay.
what an overhang and a bridge is. Okay, so
No,
I'm just trying to look for something that I can use to talk about it.
no. I'm
Okay,
sorry, I'm in
so why don't
Jharkhand,
we
so
look
my
at this?
network is so bad I cannot explain. Yeah.
Oh, don't worry. Let me know if you need me to repeat something. I will, Rajesh. Okay. So,
Yeah.
okay,
Thank
how
you.
do I get this visible? Okay. Okay. So now it will be visible. Okay, so let's take this simple box, right? Now, let's say this is a solid object. This is going to be very, very easy, right, for a 3D printer to create, because layer on layer on layer on layer, right? Now, let's say I had a stand below this, right? Now, what you're seeing is that this 3D printing has created, but when it tries to create this, it actually has to create these extensions in air. And FDM printing is fantastic, but it can't print in air, right? So this becomes an overhang, right? Now, if you just look at this lid, right? If I try to print the lid like this, it's created the 4 walls. And when it tries to print the lid, it has to print again in thin air over the 4 walls, right? So that's called a bridge.
Yeah.
Now, the thing with FDM is, on a typical FDM printer, what they recommend is, number one, don't print any angles of more than 45 degrees, right? So as I'm going up, it's going to deposit a little bit more material. So as long as this angle is 45 or more, it's fine. If it's less than 45, then there's a problem, because your print won't be very nice. And they say bridges up to 5 mm are okay. Anything more than 5 mm is a problem. So now what does that translate is, when you design something for 3D printing specifically, you want to make sure that your angles are less than 45 degrees. Your overhangs are less than 5 mm, and then you can make simple changes at designs. So I'll give you an example. It's actually a very famous example. Somebody was creating a statue, right, of a person, right? So what they did was they created the statue with the arms down. Now, when you say arms down, they're away from the body. Think of it as my body, the arms are here. You really can't 3D print it, right? So the slight modification they made was they made the arms just touching the body. So what happened was, when you're creating it, the arms they go up at a good angle, they join at a good angle, and you need no supports. Right? So always be aware of the overhangs and the bridges that are needed while printing. You can actually turn models around to print, right? A lot of people print all their models at 45 degrees, right? You want to have your supports on surfaces which are not visible to other people. For example, if you're creating a vase, if you have to create a support on the outside, that will spoil the surface. But if you find a way to attach your supports to the inside and they're still removable, that should be okay. Right? So those kind of things. Another example is, a solid sphere cannot be printed, right, very easily, because that angle becomes very acute. So a lot of designing for 3D printing is around the bevels you create, around the angles for supports, for overhangs, and you create, around the minimization of bridges. I'll give you an example. I was creating some boxes lately, right, for a dog business, and I've learned how to do 3D design for 3D printing, but I can't do 3D design. So one of the things we did was we bought models for various dogs, right, which I could then put on the lid, right, depending on the breed. So we bought about 7 models. The last one I happened to print out of those 7 was the French Bulldog. And while everything else required a bunch of support, the French Bulldog was designed in a way where it did not even require one support. It was absolutely brilliant and a very different printing experience, right? So minimize your supports, right? Look at those things and call me up. Maybe we can work together.
Yeah.
I hope that answered your
Thanks a
question.
lot. Thanks a lot. I'll definitely connect with you. We'll try. Yeah,
Okay.
I'm sorry. Can I put one more question here?
Is it connected to this
Abhishek
question,
had raised
Rajesh?
Hello.
Rajesh, your new question is connected to the current question, or it's a complete different question?
A little bit different. Different. Yeah.
Okay.
You can
May
continue
I
with
may I
someone else.
request you?
I'll come back again. I'll come back
Yeah,
again.
may I request? Yeah, sure. Because I see Mudit Jain, no, raised hand. Sorry, Abhishek raised hand. So maybe after Abhishek. Yeah, Abhishek.
Yeah, yeah, yeah.
Okay, sorry, I have muted myself. So I have one Creality printer as well with me. Uh, I purchased something long back, I think 2020 in the starting days. It's a covered printer, fully covered printer, and I have Ender 3 as it. It's an open printer. So when I start printing with both the prints, I see when I'm printing with the closed printer, the fumes are there, for which I have to open the door. Fumes are not there because of the closed and open door. Whereas 3D reality that under 3 gives some fumes, so I have to open the door. So the fumes are harmful. So I have to make some kind of way out of the fumes, or we need to have some kind of exhausting for these kind of things.
So that depends on the material of printing, Abhishek, right? PLA and PETG, right? But take everything I'm saying with a grain of salt, and I'll tell you why to do that, right? PLA and PETG typically do not create any harmful fumes, right? They don't even create the microplastic issues that we're talking about. ABS is very opposite. ABS has both fumes as well as microplastics, right? Now, why I'm saying take that with a grain of salt is that is what basic PLA and PETG is. Now, what people add into it, right? What are the additives to create the various colors and all the versions of PLA and PETG you see today, right? Whether it's PLA Plus or Pro PLA, and a lot of people have. So that is a bit questionable from that perspective. But basic PLA and PETG are quite safe to print. Now, on the ABS side, you need an enclosure to print ABS period. Without an enclosure, the ABS will not print because the layers will detach, right? It needs the temperature of the enclosure to be to go up by a little bit, right? So on and so forth. And so you cannot directly exhaust that either, right? Because it needs that enclosure. If you exhaust that, fresh air will flow in, and that will cause problems with your ABS printing. So from what I've read about what a lot of people do is they actually exhaust after they're done printing from an ABS printer, right? So they'll have an exhaust fan which they'll put on once they're done, right? I have a closed system where I have a 4-ply filter, right, for including activated charcoal, right, which I'm hoping is doing things both to gas as well as the microplastics, right? So it kind of recirculates the air within the enclosure, right? So I'm getting the temperature, and I haven't had any trouble. But I haven't smelled any of the gas that ABS is famous for either, right? Now, the one thing I have noticed is that when I'm printing PLA, I don't close my enclosure, because an open enclosure prints PLA better than a closed enclosure. PLA doesn't like that temperature going up, right? So the way I've decided to behave is that with PLA, I'm not worried. And with ABS, I am extremely worried. So I've taken all the steps, right? So that is the way I have decided to behave. If you come up against different evidence, Abhishek, please reach out to me and educate me.
Sure, sure. Thank you. Yeah.
Rajesh, you have one more question?
I think we
Oh, there is
lost
some
Rajesh.
network problem with Rajesh, and I know Omkar, आपके कुछ सवाल थे you asked during our discussions. So कोई अगर आपको सवाल पूछना है बिल्कुल पूछिए.
आवाज आ रहा है सर?
हाँ बिल्कुल आ रहा है ओमकार. सबसे पहले तो धन्यवाद
बिल्कुल
ज्वाइन करने के लिए.
थैंक यू सर, थैंक यू. मैं भी सर डिज़ाइन इंजीनियर हूँ, पुणे से हूँ मैं, और वीएफ में हूँ, मतलब वैक्यूम फार्मिंग में. मतलब हमारे ऑटोमोबाइल पार्ट्स जो रहते हैं सब, वो एबीएस में बनते हैं. तो उसका वैक्यूम फार्मिंग प्रोसेस का जो प्रोसेस है, उसमें मोल्ड डिज़ाइनर हूँ मैं.
अच्छा.
तो आने मतलब अभी तो 3D प्रिंटिंग का इतना तो प्रोटोटाइप लेवल पे ही चल रहा है सब, लेकिन प्रोडक्शन लेवल पे ये सब प्रोसेस जाने के लिए कितना टाइम लगेगा, और उसके लिए जो स्किल सेट डेवलप करना है वो कैसे करना चाहिए, इसका थोड़ा इंसाइट चाहिए था.
अरे बाबा रे, ये तो प्रिडिक्शन क्वेश्चन हो गए ओंकार. ये तो बड़ा जो मैं बोलूंगा वो गलत होगा. अब कितने से गलत होगा वो पता करना पड़ेगा, या थोड़े से या बहुत से. देखिए ओंकार जी, ये प्रोडक्शन में बहुत जगह है ऑलरेडी,
ओके.
राइट. इवन गाड़ियों में, राइट. अगर आप एंड मेटल पार्ट्स में भी है और प्लास्टिक पार्ट्स में भी है. तो वो स्टेज तो क्रॉस हो चुकी है कि ये कब जाएगा, लेकिन हर जगह नहीं है अभी. कुछ कुछ जगहों पे है, तो वो धीरे धीरे फैल रहा है, राइट. जहां पे है आप वहां पे भी आएगा. इन टर्म्स ऑफ स्किल्स कैसे डेवलप करनी है आपको, आपने वो पूछा
यस
ना.
यस.
तो डिपेंड करता है आप किस चीज के लिए स्किल डेवलप करना चाहते हैं, क्योंकि दो तीन तरीके हैं इसके ओंकार जी. सबसे पहला तरीका तो है कि आप 3D प्रिंटिंग से मोल्ड बना लीजिए और फिर एबीएस का काम कीजिए उसमें, वो भी पॉसिबल है. आप सीधा 3D प्रिंटिंग से पार्ट्स बना लीजिए, वो भी पॉसिबल है. तो डिपेंडिंग कि आप कौन से डायरेक्शन में जाना चाहते हैं, राइट, थोड़े थोड़े फर्क होंगे. स्पेसिफिकली डिजाइन में बहुत फर्क हो जाएगा, बिकॉज 3D प्रिंटिंग में हम लोग तो बहुत भक्त हो गए 3D प्रिंटिंग के आजकल. तो कभी कभी हमको नेगेटिव चीजें दिखती नहीं है 3D प्रिंटिंग के बारे में, लेकिन आज भी 3D प्रिंटिंग के बारे में अगर आप सोचें तो कि सबसे बड़ा साइज कितना बन सकता है एक प्रिंट का, और एक चीज बनाने में कितना टाइम लगता है, वो दोनों, राइट, देखने पड़ेंगे आपको मैन्युफैक्चरिंग करने के पहले, राइट. तो जैसे अब मुझे पता नहीं आप एग्जैक्टली क्या करते हैं, लेकिन अगर मैं कोई भी हवा में से एग्जांपल ले लूं, अगर आप चाहते हैं कि उसका गाड़ी का बम्पर बनाया जाए, गाड़ी का बम्पर एक पीस में तो 3D प्रिंटिंग से बन नहीं सकता, क्योंकि इतने बड़े प्रिंटर होते नहीं है ना. तो उसके या तो आप टुकड़े बनाएंगे और उनको ज्वाइन करेंगे. तो जैसा राजेश जी पहले बोल रहे थे कि उनको डिजाइन करना बड़ा इंटरेस्टिंग हो जाएगा, क्योंकि फिर वो जॉइंट्स कैसे होंगे कि दिखे नहीं और इफेक्टिव रहे, राइट, फिर भी मैन्युफैक्चर किया जा सके. ठीक है. नहीं तो आप मोल्ड बना सकते हैं वेरियस पीसेस को लेके, और फिर उस मोल्ड से आप एबीएस को मोल्ड कर सकते हैं. तो आप दोनों डायरेक्शन में जा सकते हैं. इसके लिए मैं आपको सजेस्ट करूंगा आप ट्राई कीजिए. आई एम श्योर मुझे आपका शहर नहीं सुनाई दिया. आप कौन से शहर से हैं?
पूना से सर, महाराष्ट्र.
पुणे से ही, अपने शहर से ही
पुणे से
अविरल.
हैं आप? अच्छा, पुणे में तो बहुत सारे 3D प्रिंटिंग यूनिट्स हैं, राइट. कहीं जाके आप देखिए कि होता कैसा है. अगर वो है तो मेरे घर पे आ जाइए, हम आपको दिखाएंगे 3D प्रिंटिंग मशीन. कुछ आइडिया तो मिलेगा आपको. फिर
आप पुणे
उसके
में
बाद बात कर सकते हैं कि कैसे जाना है.
आप पुणे में ही रहते हैं?
हम पुणे में रहते हैं.
ओके. तो अभी तो मैं जहाँ पे काम कर रहा हूँ वहाँ पे तो ऐसा मुझे दिखाई नहीं दिया प्रोडक्शन लेवल पे, इसलिए मैंने पूछा था.
यस.
नहीं, प्रोडक्शन लेवल पे
बिल्कुल.
गाड़ियों पे भी नहीं है पुणे में, राइट. दुनिया में है,
सर ज्यादातर
राइट.
3D प्रिंटिंग रिप्लेस करेगा इंजेक्शन मोल्डिंग. मतलब इंजेक्शन मोल्डिंग से जो पार्ट्स बनते हैं छोटे, उसको रिप्लेस कर सकता है वो. तो अगर उसका साइज लिमिटेड रहता है तो अगर उसमें होता है तो कैसे कैसे क्या सीखना चाहिए? मतलब फ्यूजन 360 है, अभी तो कटिया और यूजीएनएक्स पे काम कर रहा हूँ मैं, तो फ्यूजन 360 में सीखना चाहिए क्या?
देखिए, टूल तो आप ओमकार कोई भी यूज कर सकते हैं डिजाइनिंग के लिए,
ओके,
ठीक है। फ्यूजन 360 तो बहुत नोन टूल है। फ्यूजन 360 तो बेसिकली डिजाइन के लिए हुआ, नॉट स्पेसिफिक, सिर्फ 3D प्रिंटिंग के लिए नहीं है वो स्पेसिफिकली, राइट। वो तो आप कुछ भी डिजाइन करेंगे आप उसमें कर सकते हैं। जहां तक आप बोलते हैं इंजेक्शन मोल्डिंग को रिप्लेस करेगा, वो भी डिपेंड करता है, क्योंकि अगर आपको सेम चीज के 10 लाख पीस बनाने हैं और आपके पास मोल्ड ऑलरेडी है, राइट, तो 3D प्रिंटिंग का इस समय तो रिप्लेस करना बड़ा मुश्किल है। लेकिन अगर आपको उसी के 100 पीस बनाने हैं तो फिर तो मोल्ड का कोई मतलब ही नहीं बनता, वहां पे तो 3D प्रिंटिंग ही कर पाएगी, राइट। तो उसका क्या कहाँ रिप्लेस करेगा, वो बिल्कुल सीधा आंसर नहीं है, राइट। बहुत सारी चीजें उसमें देखनी पड़ेंगी कि आपको कितनी वॉल्यूम चाहिए, उसमें कस्टमाइजेशन चाहिए नहीं चाहिए, मोल्ड ऑलरेडी है ये मोल्ड बनाना पड़ेगा। तभी इनफैक्ट मोल्ड जितने एक्सपेंसिव है इसलिए मोल्डिंग भी 3D प्रिंटिंग में होने लगी है, राइट। तो जहां तक आप बोल रहे हैं डिजाइनिंग का, फ्यूजन 360 बहुत अच्छा ऑप्शन है, फ्यूजन 360 सीखना, राइट। उसको तो आपको इवन इंजेक्शन मोल्डिंग में भी काम आएगा, जो भी आप डिजाइन करेंगे उसमें काम आएगा, सिर्फ 3D प्रिंटिंग के लिए नहीं है वो, राइट। और अगर आपको मैन्युफैक्चरिंग साइड देखनी है तो मैं बोलूंगा कोई चलती 3D प्रिंटिंग मशीन देखिए, एटलीस्ट कुछ तो आइडिया मिलेगा क्या हो रहा है।
ठीक है सर, मैं आपको
ठीक
कांटेक्ट
है,
जरूर करूंगा, और मैं आपसे देखना चाहूंगा कैसे 3D प्रिंटिंग होता है, क्योंकि देखा नहीं अभी तक मैंने, वीडियो वगैरह ही देखे,
बिल्कुल।
फील लिया नहीं वो
बिल्कुल
मशीन पे मैंने अभी तक।
बिल्कुल। एंड इनफैक्ट ओमकार, मैं अविरल को फॉलो करता हूँ लिंक्डइन पे, और आज ही मैंने उनका एक पोस्ट देखा, तो मैं ना वो एक पोस्ट उनका दिखाना चाहता हूँ आप लोगों को। बड़ी प्यारी पोस्ट है, जस्ट अ सेकेंड। कि जो 3D प्रिंटिंग से उन्होंने किया, जो आपने बोला ना अभी रनिंग 3D प्रिंटिंग नहीं देखा है, तो उस रिगार्ड में जस्ट अ सेकेंड, ये नया टूल है
मीन
मेरे लिए, तो मैं
मीनवेल
क्या
विवेक वो निकाल के लाते हैं। ओमकार, आपको विवेक या मैं कोई एक कॉल करके आपको कनेक्ट कराते हैं एंड विजिट कराते हैं वंस विरल
यस
इज कंफर्टेबल। तो एक बार रनिंग प्रिंट 3D प्रिंटर आपको दिखाते हैं, वी विल फैसिलिटेट दैट।
ग्रेट।
ये दिस इज व्हाट कुकिंग अभी आजकल बना रहे हैं अविरल, और इसके बारे में आपने अविरल ऑलरेडी बताया आज के डिस्कशन में, तब मुझे इसके बारे में ख्याल आया कि जो 7 डिफरेंट डिजाइन आपने लिए एंड द 7 डिजाइन वाज सो ब्यूटीफुली डिजाइंड, ये बहुत इजीली हुआ। I see raised hand, but I would say that would be our last question. आज का आखिरी सवाल मोदित, हाँ आप पूछ लीजिए।
सॉरी, या नॉट अ क्वेश्चन, बेसिकली ओमकार का जो क्वेश्चन था, and there was a very interesting discussion between Avira and Omkar की molding वगैरह। तो I just like to show कि हमने अभी 3D कल्चर से एक प्रोटोटाइपिंग का प्रोसेस इनिशिएट हमने करवाया था। तो ओमकार, आपको थोड़ा उससे आइडिया भी लगेगा कि किस तरह से मोल्डिंग भी होती है एंड एक्चुअल प्रोडक्ट भी बनता है, सो नेगेटिव पॉजिटिव बोथ। मैं आपको कुछ पिक्चर्स दिखाता हूँ अपना स्क्रीन शेयर करके।
जरूर
विवेक,
जरूर,
कैन वी डू दैट?
यस यस जरूर, आई थिंक it's useful for everyone.
ओके, सो आई एम जस्ट शेयरिंग माय स्क्रीन। अभी दिख रहा है मेरा स्क्रीन?
हाँ दिख रहा है।
सो ओमकार देखो, एक डिजाइनर ने हमसे हेल्प मांगी थी कि उसको ये इस तरह की ट्रे बनानी है। अगर आप देखोगे ये सिंपल एक्राइलिक की ट्रे है और इस पे कुछ डिजाइन है। सो वो बोलेगी यार मैं इसको बनाना पड़ता है तो मेरे को पहले एक कारपेंटर को बोलना पड़ता है, वो एक डिजाइन मैनुअली उसमें चिजल करके बनाता है, एंड उसके बाद मैं उसमें क्या बोलते हैं सिलिकॉन मोल्डिंग से सिलिकॉन का मोल्ड बनाता हूँ, और उस सिलिकॉन को मोल्ड के बाद मैं उसका 3D मॉडल जो एक्राइलिक, सॉरी प्लास्टिक रेजिन रेजिन होती है, वो कौन सी रेजिन होती है यार, नाम भूल गया, बट हमें सिलिकॉन के मोल्ड के बाद में रेजिन डालते हैं, इपॉक्सी रेजिन, और इपॉक्सी रेजिन से ये
इपॉक्सी
फाइनल
रेजिन,
प्रोडक्ट
यस।
बनता है। तो 2 प्रोसेस होते हैं उनके। तो हमने उनको सबसे पहले तो वो बोला कि जो वुड का वो बनाते हैं उसमें कभी भी इस तरह का परफेक्शन नहीं आता है। तो इट इज़ अ वेरी डिज़ाइन इंटेंसिव टास्क। अगर आप देखोगे इसमें डिटेल चाहिए, बहुत सिमिलैरिटीज भी हैं डिज़ाइन में, और अगर कोई वुड से बनाएगा वो उतना परफेक्ट नहीं बनेगा। हमने उनको इस तरह से सबसे पहले 3D प्रिंटिंग मॉडल बनाया। तो ये डिज़ाइन हमने फ्यूजन 360 में बनवाया था, हमारे ही
ओके।
एक डिज़ाइनर ने बनाया था। अगर आप देखोगे पूरी सिमेट्री है इसमें, कहीं पे भी कोई इम्परफेक्शंस नहीं है। एंड वी डिड अ रैपिड प्रोटोटाइपिंग आउट ऑफ इट, कि पहले एक डिजाइन बनाया, उसमें फिर ये जो आप देख रहे हो ना, ये जो डेप्थ है, ये कितनी चाहिए कितनी नहीं चाहिए, इसमें हमने 3-4 बार करके देखा। आई थिंक थर्ड इटरेशन में हमारा ये डिजाइन फाइनल हो गया था। एक दिन के अंदर ये प्रोटोटाइपिंग हमारी फाइनल हो गई थी, जो कि वो इपॉक्सी से करते तो उनको 2-3 दिन लग जाते इजीली, क्योंकि हर बार उनको कारपेंटर के पास जाना पड़ता। दैट इज वन थिंग। अगर ये देखो आप कितना, ये बिल्कुल हर ट्राइंगल बिल्कुल सिमेट्री में है। First part is this is because of the design and the rapid prototyping, which is
Yes.
always, I mean, and which we encourage to do with 3D printing. हम हैंड टू हैंड उसको प्रिंट करके देख सकते हैं। प्लस स्केलिंग मॉडल, अगर आप ये पिक्चर देखोगे, ये बड़ी ट्रे है, ये छोटी ट्रे है, तो हम स्केल भी बहुत इजीली कर सकते हैं, सेम डिजाइन में, सेम डायमेंशंस में।
Mm.
और
This is
एंड दिस इज द फाइनल प्रोडक्ट। इफ यू सी, बिल्कुल डिटेल्स क्लियरली बिल्ट आउट प्रोडक्ट आया है ये,
ग्रेट सर।
है ना। और इसके बाद उनको डायरेक्टली, बस अगर हम इनको नेगेटिव बना देते तो उनको सिलिकॉन रबर का मोल्ड बनाने की जरूरत ही नहीं है। हम 3D प्रिंटिंग से उनको मोल्ड बना देंगे, नेगेटिव पॉजिटिव उनका खुद बन जाएगा। तो एक प्रोसेस हमने उनका ऑलरेडी एलिमिनेट कर दिया।
राइट सर।
और जस्ट
clean
टू
example.
क्विकली क्लोज दिस वन, अगर आप ये देखोगे कि ये पिगी बैंक है, उन्होंने बोला कि ये पिगी बैंक मेरे को आप बना करके दो, दिस इज ऑब्वियसली अ सॉफ्ट टॉय। तो बेसिकली वो ग्लोबल मार्केट से कुछ डिजाइन डाउनलोड, इमेज डाउनलोड करते हैं, देन वी आर नाउ हेल्पिंग देम टू क्रिएट दिस 3D इमेज आउट ऑफ दिस, ये पिगी बैंक का, एंड देन उसका 3D मॉडल बनाने का ट्राई कर रहे हैं। So this is the current work which we are doing with some people in our community.
बहुत बढ़िया. I
Nice.
see one more hand raised. So maybe quickly if you can ask question.
This is Sophia.
Sorry.
Thank you for your time. So my question is, what are the other options for better bed adhesion other than abro tape and glue stick, etc. And what the role does nozzle temperature and bed temperature plays for if we want to get better bed adhesion?
Okay, good question. Um, the most accepted forms of addition are basically the tape and the glue stick and the hairspray, right? That you talked about. That is the most common. Um, in my experience, I really haven't used them because I tend to just get good adhesion with a clean bed. Right, that's one thing. One reason I haven't started with BedG is because I have to figure out what addition I actually want to use, and then I'll get started with BedG. More, it's not because of addition, but more because BedG loves to eat glass, if you know what I mean, right? So I don't want to get BedG on my glass bed or anywhere near it. So from an addition perspective, it's all about what works for you. So if you're getting adhesion, if you're not getting adhesion, my recommendation would be start with cleaning your bed thoroughly with nothing more than soap and water, right? I would recommend the using of isopropyl alcohol. 99%, at least 95%, 91% doesn't work. Right, and just spray a little bit on and just wipe it, right? That's all that's needed, right? And use a microfiber cloth because you don't want any remnants. So your build plate doesn't have any remaining dust or skin oil on it when you're printing, right? That's what causes lack of adhesion, right? So I would try that. If that works for you, fantastic. If it doesn't, then I would try any of these three, right? Depending on what you want to use, until something works for you, right? The advantage of abro tape is that it'll be flat, right? So you don't need to do anything after you put the tape on there. The advantage of glue sticks, right, is make sure you get water soluble ones, Because then what you can do is once you put the glue stick on the bed, then you can just take a little bit of a damp cloth and even it out, right? Otherwise, if you put glue, your bed becomes uneven, right? Some places have glue, some places don't, right? So that's one way of evening it out. Right, so that's what I would recommend trying, but I think preferably try doing it without nothing. Right. As far as the temperatures go, I think that depends a lot on the material you're trying to print, right, and your specific printer, right? So I've got my bed settings fairly standard. I use 60 for PLA and I use 90 for ABS. But whenever I'm getting a new kind of roll, I always run a temperature tower, right, to make sure that I understand what temperature that particular filament is going to perform the best at. Right, but that's the way I operate. I was very happy to see I was able to print ABS at 235 because 250 was bothering me because I wasn't sure if my Bowden tube could take 250. 235 it can. So I'm very happy that I'm able to print ABS at 235. Did that answer your questions?
Great. Yep, Safia, do you have any follow-up? Okay. Thank you. There was some really good questions, nice discussions. Unfortunately, our moderator Vivek had to join another call, so he just went away. But I'll take it over, and I think we are overshooting now the call. And unfortunately, we cannot take any more questions. But if we have any questions, anyone, please write to us on connect@3dculture.in, and we will include those into the next month's discussion. But Avril, thanks a lot for joining us today. It was great pleasure talking to you, understanding and knowing your experience in 3D printing, and lots of insights we gathered. Not just the question and answers, but the other things you put some light on. So thank a lot, Abhishek, and thanks a lot all the participants for joining in.
Thank you very, very much, and 3D Culture.
Thank
Really
you, sir.
appreciate it. Thank you. I had a lot of fun, and I learned a lot too. So would love to connect with each and every one of you whenever you would like to connect, and let's continue to have some fun in this space. Thank you. All the best.
Thank you. Thank you
Thank
so
you.
much. Thank you.